draw the bending moment and shear force diagram for this overhanging beam using the relationship between external load, shear force and bending moment. So this is a overhanging beam AB of total length L. This is 2L by 3 and this is L by 3. So total length will be L by 3. So our first objective is to determine the unknown reaction forces at A and C. So at A, reaction force is RA, at C, reaction force is RC. And the resultant of this uniformly distributed load, is what? Total load is W into L. W into L is the total load, and that will act through L by 2 from A. L by 2 from A. This is A, this is B, and this midpoint, this is C. This point is C, and say this point is D. Now, if we apply equation of statics, so first let us apply, that is f of y is 0. If we apply f of y is 0, then Ra plus Rb, this reaction is at C, so Rc minus Wl is 0. That is Ra plus Rc is W into L. This is one equation. Next, we shall apply summation of all moments about A is 0. And by this, we'll get Rc into length of distance of Rc from point A is 2L by 3 minus Wl into L by 2 is 0. That is Rc is Wl square by 2 into 3 by 2L. That is 3Wl by 4. If Rc is 3Wl by 4, that is we get Rc is 3Wl by 4. Then what will be Ra? Ra will be Wl by 4, because Ra plus Rc is Wl. So we have determined the reaction forces. Now let us draw this same beam once again here. This is Wl by 4. This is 3Wl by 4, and there is one uniformly distributed load of intensity W. This is A, this is B, and this is point C. This is point C. Now let us draw the shear force diagram first by using the relationship between shear force and external loads. This is X, this is shear force axis. Let me draw it somewhere below to get more space. This is X, this is shear force. Now, what is shear force at A? Shear force at A is what? Nothing but Ra, which is Wl by 4. So there is WL by 4. Now what is shear force at just left to point C? Shear force just left to point C is VA minus total load between A to C left. A to C left. So VA we got WL by 4. And what is total load between A to C? A to C, total load between A to C is what? The distance is 2L by 3 and intensity of the load is W. So that is W into 2L by 3. And calculating that we will get what? 12 WL 3 minus 8, that is minus 5 WL by 12. So here the value was WL by 4 at point A, whereas at just left to C the shear force becomes minus 5 WL by 12, minus 5 WL by 12. So, and now what will be the nature of the shear force between A to C? Because we know that another equation, we know that dVx by dx is minus W. Here intensity is constant, intensity W is constant. So slope of shear force is constant, that means shear force is straight line. Slope constant means shear force is straight line. This is the straight line. Now, what is shear force just right to point C? Because at point C there is a concentrated load 3 WL by 4. So VC right, that is shear force just right to point C, is VC left minus this concentrated load. Minus this concentrated load. This concentrated load is what? Minus 3 WL by 4. Why minus? Because our sign convention was that concentrated loads are positive when they are downward. This is upward, so this will be minus. So VC left was minus 5 WL by 12 plus 3 WL by 4. That becomes 12 minus 5 plus 9, that is 4 WL, that is WL by 3. So just to, there is a sudden rise in shear force and that goes to here, that is WL by 3. Then what is shear force at point B? What is shear force at point B? So shear force at point B is shear force at point C right, just right to point C, minus total load between C right to B, between C right to B. VC right is WL by 3. And what is total load? This length is what? This length C to B length is L by 3. So that is also minus, intensity is W, length is L by 3. So that is also WL by 3. So that becomes 0. So shear force at point B becomes 0. So this completes the shear force diagram. Now our next objective is to draw the bending moment diagram, that we shall draw in the same page. So we shall erase these calculations of shear force diagram. Now what is MA? What is MA? that is bending moment at point A. What is bending moment at point A? That is 0, because this is a hinge joint and hinge joint produces no bending moment to the beam. So MA is 0. So first let me draw it. This is for bending moment. So MA is 0. Now what is MC? MA is 0. Then what is MC? Or first let me locate this point once again. Let me locate this point, that is C, and this point is D. At D, this point is D where shear force is 0. So first let us calculate what is MD. MD is what? Or MD is MA plus total area under SFD between A to D. So what is total area of SFD? This area. Now what is this area? We know that height is WL by 4, but we do not know this length. What is length AD? What is length AD? Say length of AD is P. So WL by 4 by P is what? 5WL by 12 into 2L by 3 minus P. 2L by 3 minus P. So from this, omega L is cancelled. 4, that is 3. So that becomes what? 1 by small p is equal to 5 by 3 divided by 2L by 3 minus p. That is 5p by 3 is 2L by 3 minus p. If we take p this side, that becomes 8p by 3, that is 2L by 3, or p is L by 4. So this distance p is nothing but, so erase p here, and that is L by 4. At L by 4, shear force becomes 0. At L by 4, shear force becomes 0. So p value is L by 4. Now let me erase this part because this is not required. This is not our interest right now. We have determined the length where shear force becomes 0. Now what is that area of that triangle? What is this area? Triangle, this triangle area. Area of this triangle will be what? That is that total area becomes half into WL by 4 into WL by 4 into length is L by 4. That is WL square by 32. This is the area, total area. Now MA was 0, so MD becomes what? 0 plus WL square by 32, so that is WL square by 32. And this, as shear force is straight line, so this area, this nature of bending moment will be parabolic. How it will vary? That is at L by 4 it becomes WL square by 32. It becomes WL square by 32. After that, shear force becomes negative. So the area under shear force diagram, this area, this red hatched area is negative. So from this WL square by 32, shear force will fall. And what is the value of shear force at C? That is MC. MC is what? MD plus total area under shear force diagram between C and between D and C, between D to C. So what is that area? If that is L by 4, then what is this length? First calculate what is this length. This length will be 2L by 3 minus L by 4. What is that length? Let me calculate it here. 2L by 3 minus L by 4. That is 12. 8L minus 3L, that is 5L. 5L by 12. So MD was WL square by 32 plus this area of this triangle, as this is negative shear force, so this area is nothing but negative area. This is negative area. So that is going to be half minus 5WL by 12 into 5L by 12. That is WL square by 32 minus 12 into 12 is 144 into T, that is 288 into 25 WL square, and that becomes 288 288 divided by 32 is 9. So 9 WL square minus 25 WL square, that is minus 16 WL square, and that is nothing but 288 divided by 16 is 18 WL square minus 18 WL square. So this becomes at C value of bending moment is minus WL square by 18. So this curve going to come to here, and this value is minus WL square by 18. Now, what is bending moment at B? That is the free end. Bending moment at B will be what? Bending moment at B will be MC plus total area under SFD between C to B. That is, we know WL square by 18 MC. Now this area, that is this area, this green hatched area, this is the area. This area is positive area. This is positive area. So we have to add this area. And what is this area? This area is going to be half into WL by 3. This is the height, and length is L by 3. So that is going to be WL square by 18. So this has to add with MC. So that is plus WL square by 18. And that going to be 0. And nature of bending moment diagram, that is shear force is straight line. So bending moment will be parabolic. So parabolic in nature. So this is parabolic in nature and going to be 0. Now we have observed two things here. We have to note two things. What are those? That is at this point, at L equal to, at x equal to L by 4, at x equal to L by 4, at x equal to L by 4, shear force is 0. So Vx at L by 4 is 0. And here bending moment is maximum. Here bending moment is maximum, M max. And this is positive value of maximum bending moment, that is WL square by 32 we have determined. Another point at 2L by 3, x equal to 2L by 3, here also shear force is 0. This is the shear force 0 value. And we got here also maximum bending moment. This is also another maximum bending moment. So one is for positive value bending moment, one is negative value bending moment. So we have noted that where Vx is 0, their bending moment is maximum. Why? Because bending moment will be maximum when bending moment will be maximum when dmx by dx is 0, and that is nothing but Vx. So where shear force is, we have to note that bending moment is maximum when Vx, or mx is maximum when Vx is 0. When Vx is 0. And we have to note another thing, that is at this point, bending moment changes its sign, and this point is called point of inflection or point of contraflexure. So the point where bending moment changes its sign is called point of inflection or point of contraflexure. So we have noted 2 points, that is the point where bending moment changes its sign, it's called point of inflection or point of contraflexure, and this point is seen is overhanging type beam. This point is seen in overhanging beams. This is a overhanging beam. So we have got one point of inflection or point of contraflexure. And another point we have noted, where shear force is 0, their bending moment will be maximum. Now we got here two maximum bending moment. One is positive, another is negative. The positive and negative sign implies nothing but the sense of rotation. Bending moment is positive when it tends to bend the beam concave upward, whereas the sense is opposite, then we will call it negative bending moment. So this bending moment, sign of bending moment, is nothing but the sense of rotation. So that is nothing but sense of rotation. So we will consider that this is the maximum bending moment, and due to this maximum bending moment, maximum bending stress will occur in the beam.